an object of unknown mass is given a push which gives it a velocity of 3 meters per second, and the object thus starts to move up an incline at 22 degrees. Now the force that is acting in the downward direction is the mass times the acceleration, or mass times acceleration due to gravity. And if we assume the mass of the object is m, then the force acting in the downward direction is 9.m newtons. Now, this force has two components, one that acts along the incline, the direction of travel, and another force that acts perpendicular to the plane of motion. Now let's consider along the incline. This would be 9.8 m times sine 22 degrees. Sine 22 degrees is 0.38. Therefore, the force is 9.m times 0.38. But this force, if we assume that the body is moving up with a negative acceleration of ax, then this force that is acting along the incline is also mass times acceleration, or m times ax. So 9.8 times 0.38 is equal to m times ax. M and m cancels out, and we get that the acceleration is 3.72 meters per second squared. The question that is asked is how far up the incline will the object travel, and how long will it take to return to the starting point. Here are the things that we know. The initial velocity is 3 meters per second. When the object gets to the top of the incline and stops, the velocity will be 0. The acceleration we just found out is 3.72 meters per second squared. So let's use the equation. V final squared is V initial squared minus 2 times the acceleration times the unknown distance. Substituting for all that we know, we find x, the distance that the object travels up the incline, to be 9 divided by 7.44, or 1.2 meters. Now, using the equation, V final is V initial minus the acceleration multiplied by time, we get the time is the initial velocity divided by the acceleration, or 3 divided by 3.72 is 0.8 seconds. That's the time it takes to travel to the top. So to get back to the bottom, the total time would be 2 times 0.8 seconds, or 1.6 seconds.